Filter effects make video calls so much more fun. Let's learn how to build them. Video calling apps have become an essential part of our lives. They help us stay connected with friends around the world, and for businesses, they are a vital part to stay productive and efficient in their work. Snapchat, Instagram, and TikTok are just a few examples of applications that use video filters to allow their users to express themselves in fun ways. Effects like googly eyes, glasses, and beauty filters have become common features. We will be using the powers of DeepAR to bring these filters to a video calling app using SwiftUI. But hold on. Let's take a step back and think of the benefits this brings. First, it adds a layer of creativity for users to express themselves in playful ways. Second, it will add a personal touch despite the distance. Third, it will give a competitive edge through providing features that other apps simply don't have. And lastly, it will increase the time users spend on calls, leading to higher engagement metrics. Businesses love this. So we all agree on the fact that adding these filters will make the app better for everyone. So let's explore how to build this. Short disclaimer, the final code can be found on GitHub, and I will add the link in the description. Before we start, let's quickly go through the project and the way it's set up. For the video calling feature, we will use the Stream Video SDK. Check the link in the description to get started for free. The way video calling apps usually work is they take the raw camera frame, upload it to a server, and the server then distributes this image to the other participants. However, we will intercept each frame from the camera, hand it to the DeepAR SDK for processing, which will then add the video filter. The Stream Video SDK will then upload this processed image to the server, and the server will distribute it to the other users. We will start by setting up a new project and integrate Stream to create the video calling feature. Let's get started. Let's get started by creating a new Xcode project. We will select an iOS app. We will give it a name. Make sure SwiftUI is selected. Hit next. Save it somewhere on the machine and wait for Xcode to build the project. Now the first thing we need to do is we need to add the dependency for Stream Video. So we head over to the project file here, go to Package Dependencies and select the plus icon. Now we need to enter a package URL. So let's switch to the browser, and here is the Stream Video package on GitHub. It is fully open source, so you can take a look at all the code that's written inside of it. We will copy over the link and paste it here in Xcode. We will select it and go for up to the next major version and hit Add Package. Now we need the Stream Video package, since this is the low-level client that contains all the logic for the package, and we want the SwiftUI one because we built our app with the SwiftUI and it gives us a lot of built-in components that we can use for our app, and we don't need the UIKit version because we're not using it. Let's add the package. Now we wait until it's finished, which it already is, so we can go on. In order to initialize Stream Video, we first need to create a project in the dashboard and obtain an API key. So we switch back to the browser and go to dashboard.getstream.io. Link will be in the description. Now we can create a new app here with the Create New App button, give it a name, and select locations and click Create App. We already did that here, so let's take a look at how this will look. Here you can see all the relevant information, for example, the API key that you can copy here. Now we want to create a basic demo user. So let's create a new Swift file. Call it user credential and create it. The first thing we need to do is to import Stream Video. Next, we will create a struct with a user of type user and a token which will be of type user token. Finally, we want to have a way to have easy access to a demo user. So let's create an extension that just has a demo user as a static variable. It will have an ID, a name, an image URL, and we need to add a custom data object as well. And we need a user token for access. We've added the user and the token in code, but we still need to introduce it in the project. This is where usually a server will come in that will handle these kinds of requests. For simplicity, we'll skip this step and just do it directly in the dashboard. Switching back to the dashboard, we can see we have the key here and the secret. We will need that in a second, but first we need to create a user. So if we go to Explorer, we will see the different channels, users, and everything that is available in our application. So here for users, we can create a new user, give it a username that we like, give it an ID that we like, and we need to select the role of user. We've already done that here, and you can see the test user here with all the credentials that we need. Now the second step is that we need a token in order to authenticate with the Stream backend. Luckily, there's an easy way to do this because we have a tool that you can use during development to generate tokens. What we need for that is the secret of the application that we can go to overview and copy here. And then we can go to our JWT generator and include the secret here, as well as the user ID. We will get a token and we can copy this and paste it into our app. The link for the token generator will also be in the description. So let's switch back to our application and we can paste the newly generated token here. Great job. Now we are ready to initialize Stream Video in our app. Let's head over to our app file. First, we add the dependencies for Stream Video and Stream Video SwiftUI. Then we will add a state property for the Stream Video UI object. This will be used to initialize the package. So let's create a function that does exactly this. We set up Stream Video with an API key and some user credentials. And then we simply call the Stream Video UI object. We put in everything that we created previously. In a real application, we would have some logic here to generate a token dynamically. Remember, we skipped this for development purposes. And then finally, in the content view .onAppear, we call the setup stream video function with our API key and the user credentials that we just created. Now we need some way to initialize a call, so let's create the UI for that. We switched over to our content view and first get rid of the auto-generated code. Now the preview will crash, so let's close it for now. So first again, we need to add Stream Video and Stream Video SwiftUI as dependencies. Next, we will inject the Stream Video object. We can do this handily with the add injected property wrapper that is part of our dependency injection mechanism. If you want to read more about this, I'll add a link in the description. Next, we create a call view model, which is an object from the Stream Video package that will handle all the calling functionality for us. We will also add a call ID. Next, we create the UI, which will be a simple VStack that has a text field and a button. The button will simply start the call with the call type default and the call ID that we can create in the text field. Now you might wonder, how can we create the UI for the call itself? And luckily this is very easy. We simply need to add the modifier of type call modifier and inject the call view model. That's all the code needed to create video calls. Let's take a look at how the app will look now. We can enter an ID and hit the Start a Call button. And after waiting for the call to initialize, we can see the app is working, but there's not a lot of fun without having filters, right? Now that video calling works, we want to prepare the video filters and effects. As we've already mentioned, we're using DeepAR for that. In order to get started, we need two things. The first one is multiple filters that we can add to our application. And the second one is we need to create a DeepAR account and add an application in their dashboard. So let's take a look how we can achieve this. In order to use video filters and effects, we have two choices. We can create filters and effects using DeepAR Studio. It's a free download and you can take a look how it looks here. So there's different effects that you can use as templates, or you can go with the new project and create our own. We won't do this here, but we have prepared some filters for you. So if you go to the GitHub repo of the project, link will be in the description, and download this either by cloning it or downloading it via a zip file, you can simply take the effects that we created. So let's do this and add them to our project. Let's head over to the desktop. I've downloaded the project. I can navigate inside and just take the effects folder, which contains some examples of .deepar filter files. And we can just drag this effects folder over here. And we make sure copy items if needed is selected and add it to the target and select finish. Now we have the effects here. And we can have a look at them here, but they won't show anything. So let's add them to our application. First, we will create a new Swift file. Call it effect. And we will initialize it with an enum called effect that is of type string, and it is iterable. And then we add cases for each of the filters that we just added together with a name. We also add a path variable that is a dynamic variable, which we will use to load these files from the file system when we need them. Next, we need to create a DeepAR project. So let's head over to the browser again, and we go to developer.deepar.ai. I will add the link in the description. And we can create a new project here. So let's do this. New project, give it a name. Select how many users we want. We are fine with just 10, which means it has a free tier for this, which is great. And we can now add an application for iOS. We need to add the bundle ID. So let's grab that from our Xcode project. We go to project, select the app as the target, signing in capabilities, and go with the bundle identifier that we paste here. And we hit continue. That's it. We can now copy the SDK key that we will need in a second. Awesome. The next step is to add the dependency for the DeepAR SDK in our application. So we can get the link for that from GitHub. I will also include it in the description. And we can head over to Xcode, go to the project, package dependency, hit the plus icon, copy this URL here, and add the Swift DeepAR SDK. While we wait, let's drink a coffee. We wait a little bit more. And some more. And we can add it to our target, hit add package, and we're ready to integrate it into the application. In order to use and work with the DeepAR SDK, we will create a view model to help us with that. So let's create a new file, Swift file, call it filters service, and create it. As usual, we first add the dependencies. We need SwiftUI, stream video, DeepAR, and the core image package because we will do some manipulations on the images. Then we will initialize our filters service class as an observable object, and we will add the main actor property wrapper because we want all UI relevant actions to be run on the main thread. Next, we will have some properties. We will have the filters active property, which will indicate to the UI whether filters are active or not. and the selected effect so that we can select them in the UI and we will handle them in this view model. We will also have the DeepAR object and a DeepAR filter, which is of type video filter that we'll get to in a second, and the current processed image. Next, we initialize our filter service. We first call the super.init on the MS object that we're inheriting from, and then we initialize DeepAR. This is simple. First we create the object, then we set the license key, we set the delegate to be self, and we'll add that in a second. And now we need to change the live mode. We will not use the UI that DeepAR gives us. We could, but we won't in this use case. And finally, we will create a DeepAR filter. We'll create the function that will return the video filter object. Then we will initialize a DeepAR video filter, which is the video filter object. It allows us to add a filter over the current image, and the Stream Video SDK will take care that it is applied and the camera frames are processed. So first we take the image and we rotate it, so we'll have it in a portrait position. Next, we will see if the rendering is initialized on the DeepAR SDK. If it is not, we will initialize it off screen with the image extent and width and height that we get from the rotated image. We will then load the path of the current effect and switch the effect to the current one on the DeepAR object. Note that this is not very memory efficient. In a production app, we would want to initialize the DeepAR SDK beforehand so that we don't see any spikes during the processing of the images. For simplicity, we will keep it like this. Finally, we take the rotated image, convert it to a CV pixel buffer. We will create the extension for the image in a second, and then hand it to the DeepAR SDK to process the frame. We will then either return the current processed image that we get, or simply return the rotated image, which hopefully should not happen. In the end, we will return the DeepAR video filter. So what we're doing here is whenever this video filter is applied, it will get each camera frame here. We will convert it and send it to the DeepAR SDK to process this frame. We will see where this is handled in a second. The last function we need to add to our view model is to have a way to select filters. And what we do here is we simply load the current path of the effect and then switch the effect in the DeepAR SDK. In order for our code to compile, we first need to conform the filter service to the DeepAR delegate. So let's do this. We create an extension for the filter service to conform to DeepAR delegate. There's a few convenience functions that we can use, but we won't in our case. So for example, once we have tracking of a face, we can take this data. Once the visibility of a face did change, we might hint at the user that something has changed, and we see some finish shutdown and initialize functions. The most important one that we are interested in is the frame available function. What this does is it is called whenever the DeepAR SDK is finished processing one of the images we send to it using the process frame function. What we will do now is we will take this CM sample buffer, convert it to a pixel buffer, create an image out of that, mirror that image using the transform, and then assign it to our current processed image. Remember, this current processed image is exactly what gets picked up by our filter. So we will take the latest one that has finished processing and return it to the Stream Video SDK. Now this code still won't compile because we are still missing the convenience function of converting our CI image to a pixel buffer. So let's add this extension below. I've copied over the code and I've taken this snippet from Omarojo on GitHub. He provided this gist for us, which is great. And we just copy this to our project and take it. With that, we have prepared all the necessary logic to add these filters during our video calls. Awesome. We have prepared the filters. Now we want to add them to the UI and be able to activate and select them. For that, we need to follow 3 steps. The first is we need to introduce the DeepAR filter object from our filters service to the stream video UI object. Next, we need to prepare the UI elements for activating and selecting video filters. And third, when on a call, we need to show this UI for the user to be able to use it. Let's go. We are in the app file of our project. First, we will create a new filters service object. It is a state object, so we say the app file is the owner of this object. Now, our stream video UI object needs to know about the video filters that we want to present to them. So let's add that. In the stream video UI initialization, that's a difficult word. Initialization. We will create a video config object that has the video filters and takes the filter service.deepAR filter that we previously created. Now we need to create a user interface to select filters and activate or deactivate them. Let's create a new SwiftUI view. Call it filters picker. Now first we will add the dependency for the stream video SwiftUI SDK. Next we will have some observed objects that need to be handed into the filters picker. First we have the call view model and then we have our filters service. We will place the UI in an H stack and first have a toggle that specifies whether a filter should be applied or not. We will make this dependent on the filters active property of the filters service, which, if you remember, is a published property, so whenever it changes, our UI will trigger an update. Whenever it changes, we set the video filter on our view model if it is true, so if a video filter should be applied, and if not, we set the video filter to nil, meaning we just use the regular camera feed in the SDK. Now we can say if the filters service.filters active is true, we will use a picker and add the selected effects here. And then we just go over the effects. Remember, that's the enum that we created earlier, and take the raw value as a name for this. This is tied to the selected effect published property of our filter service. So whenever that changes, it will automatically trigger an update again. Now we'll make this look a little bit nicer, give it a nice background of a thin material. And finally, our preview is not working, so let's add the view model and the filters service here. Now this is all the UI we need to change and activate the filters that we want. In order to show our UI, we need to head back to the content view and first say we want a filter service object handed to it. Then we have a Z stack at the root of our UI here. So whenever we say the call view model.calling state is in a call. This is, for example, where a call view model object will come in very handy because we will get this out of the box from the SDK. So if we're in a call, we will add the filters picker to the UI and the user can interact with it. Again, let's fix the preview and add the filters service here. Now the app won't build because we need to hand in the object of the filters service to our content view. So let's do this. And that is all. We have finished the code and are now ready to explore the end result. Hey man, how are you doing today? Hey man, I'm doing great. Okay, but don't you look a bit odd? I'm not sure what you mean here. Oh, okay, never mind. Can we start with the meeting now? Sure, let's get started with the meeting. Where can we go next? For a real application, we would definitely need some proper user management. We can create and add new filters and effects using DeepAR Studio. Feel free to try things out, get started for free using the link in the description, and tell us what you built in the end. The best submission will get a thumbs up from us. Thanks a lot for watching. We hope you learned something new and see you next time. And don't forget to like and subscribe to the channel, of course. Of course.